modes, light tends to travel the fiber length in the same time. That means while providing the graded index fiber throughout the material, the refractive index of the core is different from the center while traveling towards the interface. That means from the center while traveling towards the interface, the refractive index is gradually decreasing, and as a result of it, the velocity of the light pulse is increasing through the material, and as a result of it, in the output of the material is good, and there is no time changes or no time variation is found, and pulse can be transmitted though through all modes, but it can reduce the dispersion in multi-mode graded index fiber in comparison to MMSI. Let us observe the diagram for that. You have to draw the diagram for MMGI. You can see that in projection, multi-mode graded index fiber. Here also it is the material. You can see that N2 is the cladding. Here eta 2 represents the refractive index of cladding. In the center portion, eta 1 represents the core. Here this diagram represents that this portion represents the cladding portion, and the center portion, you can see that this hilly region, green color, represents the core. You can see that the shape of the core is not regular like the shape of the cladding. That means here at the center, the refractive index is constant, but while traveling outward towards the interface, the refractive index is gradually decreasing, and in the same manner refractive index is inversely proportional to velocity. You can observe the pulse which is traveling from the optical fiber. That means through this, when light input or signal input is given or the light ray is transmitted through this optical fiber, this light ray will constantly get reflected and bend at the interface and will pass through this denser region, and it will try to penetrate to the denser region of the interface. That means you can see that it will be observed that the light is traveling in a sinusoidal portion. So in the output there will be no variation in time, and the output will be of less dispersion. We can just move towards the slide. Even though all modes, light tend to travel the fiber length in the same time. Even though all mode of light tend to travel the fiber length in same time in comparison to MMSI. This fiber can therefore handle higher bandwidth and provide longer length of transmission before pulse effect destroy the transmitted pulse. So the time travels the fiber length in the same time, though all different path lengths, the pulse travel at the same time and reach at the output before pulse effect destroy the transmitted pulse. Light is propagated down this fiber through refraction. Consequently, the light rays are constantly being refracted, resulting in a continuous bending of light rays, and thus the path of travel therefore appears sinusoidal. As I said, due to constantly refraction at the interface due to decreasing core of refractive index, the light rays will bend at the refracting side and it will appear as a sinusoidal portion. That means MMGI, that is multi-mode graded index, has a bandwidth of 1600 megahertz per kilometers. You can see that in bracket LAN. LAN represents that it can be used in communication in compared to MMSI. Let us move towards the next question. Superconductivity. Write the definitions of three important factors to define a superconducting state. In GTU paper solution, this question was asked for 3 marks. So it can be asked in 3 to 4 marks in your GTU paper. In January 2013, this question was asked for 3 marks. So let us define that. The question was asked that write the definitions of 3 important factors to define a superconducting state. Here we are getting a solution for this question. In this solution, you have to write each and every definition for these factors, for these 3 factors, as well as you can also represent the equation if it is there. Let us move to the answer. The 3 important factors to define superconducting state are, you can see that first, critical temperature, Tc is the first factor. Second, critical current density, Jc represents the second factor, and third factor is critical magnetic field, that is Hc. So these are the 3 factors or the 3 important factors through which you can define superconducting state. Let us observe the first thing, critical temperature Tc. The temperature at which material's electrical resistivity drops to absolute zero is called the critical temperature. It can be represented as Tc in a symbol, and it can be represented as transition temperature. That means critical temperature can be also represented as transition temperature. Let us repeat that. The temperature at which the material's electrical resistivity drops to absolute zero, it is called critical temperature. That means a particular temperature value at which the resistivity will tends to zero, and that temperature is called the critical temperature, or you can also name it as transition temperature. The second point is, you can see that critical current density, and the third definition is of critical magnetic field. First of all, we will define critical current density, and then we will define critical magnetic field. Here you can see that critical current density Jc, the symbolically it is represented as capital J, and C represents in suffix, this C represents the critical. It is defined as the maximum current that can be permitted in a superconducting material without destroying its superconducting state. I repeat, it is defined as the maximum current that can be permitted in a superconducting material without destroying its superconducting state. In equation, it can be represented as J is equal to IC upon A. Jc represents the current density, which is equal to the current in a superconducting material per unit cross section area. That is Jc is equal to IC upon A. So while defining it, you can also write the equation for that definition. And let us move towards the third factor, and the third factor is critical magnetic field. The minimum magnetic field required to destroy the superconducting state is called the critical magnetic field Hc. I repeat, the minimum magnetic field required to destroy the superconducting state is called the critical magnetic field Hc. Here in this equation, this is the equation for critical magnetic field. This is the 3 factors for or to define superconducting state. Here Hc represents the critical field. Here H0 represents the critical field at 0 Kelvin temperature. T represents that temperature, and Tc represents the critical temperature. So in this manner, we can define the 3 factors which are necessary to define the superconducting state of the material, and in this manner you can obtain 3 marks while writing in this proportion. Let us move towards the next question in our slide. Name the types of biomaterials and explain any one. This question is asked in 3 marks. Name the types of biomaterials and explain any one. So while writing the types of biomaterial, you can write and explain any one of them, and you can obtain 3 marks for it. As I have shown you in this presentation, you can just get an information that what should be the proportion to write or to answer this question for 3 marks. The biomaterials are generally classified into the following types. So I have written here 4 types of biomaterials, and from which you can explain any one of them. You can see here the types are: first, metal and alloys; second, polymers; third, ceramic; fourth, composites. Here, for example, I am just explaining the proportion of metals and alloys, which is one of the synthesized biomaterial. These 4 are the synthetic biomaterials which are normally used in various engineering applications. Actually, biomaterial is one of the advanced engineering materials. You can see it in the topic that in the top portion of this presentation, new engineering materials. This topic or this question is taken from new engineering materials or latest advanced engineering materials. So these are the types of biomaterials. Let us explain one of them. You can also explain any one of them. The 3 major materials. First of all, you have to just write the names of metals and alloys which are used in engineering applications as a biomaterial. These are the 3 materials. You have to write these types of materials. Stainless steel 316L. It is a type of metal and alloy which is used as a biomaterial. Second, cobalt, chromium, molybdenum alloy. And third, pure titanium and titanium alloys which are used as a biomaterial in engineering application. You have to explain it also that where it is used. Let us see here. Metals are most widely used for load bearing implants due to their high mechanical strength and toughness. Metals and alloys are having load bearing capacity. So implants, as an implant device, that means to take the position of the original one for load bearing instrument, metals and alloys are always used as load bearing implants due to their high mechanical strength and toughness in comparison to other materials. For suppose polymers are not able as to use as load bearing implants. The implants made of metals includes simple wire, screw, fixation plates, total joints, artificial joint for hips, knee, shoulders, ankles, and so on. You can see the names of joints for hips, knees, shoulders. That means these materials, metals and alloys, are used in the application for orthopedics. That means in a fracture or a surgery of bones or fixations, this type of metals and alloys as a biomaterials are used. Though metals and alloys are biocompatible, you can see the new points on it. See, metallic implants are used in maxillofacial surgery, cardiovascular surgery, and also as a dental materials. The implants such as stainless steel, titanium, cobalt alloy are generally biocompatible, but some people are allergic to it. So if this material corrode inside it, and if ions are released during it, allergic disorder can be created in some people if they are allergic to this ionic degradation by corrosion. The drawback of this material is, the major drawback with metal as a biomaterial is the generation of fine wear particles in service that can lead to inflammation to your skin or body and implant loosening. So this is the question to explain the new engineering materials, the types of engineering materials, and you can explain it anyone. So this should be the proportion if this question is asked. Let us move toward the last question of this lecture. The last question is, distinguish loudness and intensity. To distinguish this question and to answer that question for 2 marks, you should minimum write 4 points to distinguish loudness and intensity. Let us observe the answer for that. You can see that it is the degree of sensation produced on ear, loudness and intensity. That means for 2 marks you supposed to be writing 4 points. Loudness is the degree of sensation produced on the ear, as well as intensity is the quantity of sound energy flowing per unit area in unit time. That means intensity represents the energy flowing and loudness represents the degree of sensation. Second, it varies from listener to listener. That means loudness varies from listener to listener, whereas intensity is independent of listener. Loudness is a physiological quantity, whereas intensity is a physical quantity. Physiological quantity, that means in contact of human beings. The quantity represents the physiological thing. The unit of loudness is sound and the unit of intensity is watt per meter square. So this must be the proportion of question when it is asked as a distinguishing question for 2 marks. So this was the last question which we were solving for GTU question for this lecture. Thank you.